Assalamualaikum and hi. So in this video we are going to look on the solution for question 5 of the mock question of set 4. So in this question we are provided that we have a single component circuit that is the pure resistor, and it is connected to an AC voltage, and we are provided by a general sinusoidal equation of voltage supply. So we can start this question by representing this equation provided with the general equation, that is V equals to V naught sine omega t. Okay, so this is the comparison. So we know that the 12 here is our V naught, and then 100 pi is our omega, and T is T, and V is the voltage supplied across time. And for the first question, we are required to calculate the peak current. Peak current means it is I naught. So the information that we have in this question is V naught equals to 12 volt, and also we have pure resistor R is equals to 1 kilo ohm. And therefore we can use the Ohm's law, which is V equals to IR, and apply in V naught equals to I naught R, and we can find our I naught as V naught 12 volt divided by 1 times 10 to the power of 3 ohm, and you will get your I naught as 0.012 ampere. And for the second question, we are required to calculate the RMS current. So it is I RMS, and we know the equation related to I RMS is I naught over square root of 2. Since we have calculated I naught from the previous question, we substitute in 0.012 into this IRMS equation. So we will have our IRMS as 8.49 times 10 to the power of negative 3 ampere. And the third question, we are required to find the phase angle between the voltage and the current. So the voltage and the current in pure resistor, the graphical sinusoidal representation will be in phase. That means that we will have a graph against time of V and I, which is the voltage and current starts at the same time and finish at the same time. So they are in phase. This is the voltage and this is the current. So we know that they are in phase. Therefore, in phasor diagram, there are no angle between V and I. So V and I is in the same direction. So the phase angle is 0 degree. Or you can say they are in phase or 0 degree. And the last question will be, write an equation for the AC current. So the equation provided in the question is for the voltage supply. So we have to write for the current. So the general equation should be I equals to I naught sine omega t. So I naught have been calculated from above, that is 0.012, and then omega is the same as provided in this general equation, which is 100 pi, and therefore we can write our general equation as I equals to I equals to 0.012 sine 100 pi d. So this is the general equation for the AC current, and I is in ampere and t is in second. So that is for the first part of this question 5, and let's continue with question B. So question B, we are provided with a RCL circuit. So it is a combination circuit of 3 components, that is resistor, inductor, and also a capacitor. The circuit is connected to a 20 volt AC source and frequency of 1 kilohertz. So it's easier if you take the information out. So we have R equals to 120 ohm, L is equals to 20 millihenry, and then capacitor is equals to 3 microfarad, and frequency equals to 1 kilohertz. And for the first question, we are required to find the reactance for the capacitor and inductor. So the reactance for the capacitor will be XC. So XC is 1 over 2 pi F C. So we have the information of F, and we also have the information of the C. We substitute in, and it will be 1 over 2 pi. F is 1 kilohertz, so we have to expand it, so it will become 1 times 10 to the power of 3, and multiply by the capacitor, which is 3 times 10 to the power of negative 6 farad. And finally, the XC will be 53.05 ohm. So the reactance has the unit of ohm. And the next one is the reactance for inductor, which is XL. So XL can be calculated by 2 pi FL. We also already have all the information. We substitute in the same information of frequency, and the inductance is provided by 20 millihenry. Substitute in, and you will calculate this, and you will get 125.66 ohm. And also it will have a unit of ohm. And the third question, for the second question, we are required to find the RMS current. So how do we calculate the IRMS, which is the root mean squared or average current? Since in sinusoidal form of voltage and current, we do not find average, but we find RMS. So this is the combination circuit. So we can use based on the Ohm's law, compare the Ohm's law with the circuit that has impedance, which is the combination of the R, C and L. We will have V equals to I, Z. So our resistor here has become Z of impedance because of combination circuit. So we have the value of voltage, which is provided as 20 volt over here, and then we are required to find I. So we have to find Z with the value that we already have. So Z can be calculated by square root R squared plus XL minus XC squared. So we have the value of R, XL and XC has been calculated, and we will just substitute in square root. R is 120 squared plus XL is 125.66 minus XC as 53.05 squared and square root all of this, and our impedance will be 140.26 ohm, and this is already Z, so we have to calculate our RMS current. So we will have V equals to 20 volt, and then Z is equals to 140.26 ohm, and V equals to I Z. So V is, because V is the V of the 20 volt provided is the source, so the voltage is RMS, and therefore the I that we are calculating here is also RMS. So I RMS is equals to V RMS over Z equals to 20 volt divided by 140.26 ohm, and you will get the answer as 0.143 ampere. Okay, so the next question is the phase angle of the circuit, which is the phi or theta. So we can calculate tangent phi equals to XL minus XC over R. Okay, so in order to, since we already have the value of XL, XC and R, we can calculate phi as reverse tangent. Inverse tangent of XL is 125.66 minus 53.05 divided by 120 ohm, and the theta will be 31.18 degree. And finally, the last question asks for average power of the circuit. So average power is calculated by IV cos phi. So we already have the I RMS, we also have V RMS, and we also have found the phi, and we can substitute in all the value that we have, and we can find our average power. And when you calculate this, and finally you will get 2.447 watt. Okay, so that's all for question 5. All the best.